Okay, so this is problem 2.4.27, and they're asking us, or telling us, that a survey was conducted among 61 cities to determine the sports teams in that city, and they're telling us to let B equal the set of cities with baseball teams, F is going to be the set of cities with football teams, and L is the set of cities with lacrosse teams. Okay, and then they're giving us a bunch of information here in set notation, and they want us to answer a bunch of questions. Okay, so this is really going to require us to create a Venn diagram to be able to answer the question here, the questions. So I'm going to start with the universal set because we're talking about 3 sets here. I'm going to give myself 3 circles to work with, and I'll label them B, F, and L for the 3 sets that we're working with. And then when we're trying to do a Venn diagram like this, we really want to start with the innermost intersection. It's going to be the place that we'll have to build everything else from. So if I start with this right here, the number of elements in the intersection of B, F, and L, the intersection of B, F, and L is this region right here, and it's telling me that I have 4 elements there. Okay, so I'm going to place a 4 there. Check that one off my list. And then really I need to go to these 2 next. These are the intersection of B and L and B and F. So the intersection of B and L is going to be these 2 regions right here. And so if I have 9 total and I've got 4 in this region, then I have to have 5 in this region to make up that 9. Okay. The same reasoning is going to be true of the intersection of B and F. It's the same number here, so 4 there means 5 there in order to make up the 9. Okay. Alright, so the next thing that we want to look at, you actually could go and take care of the number of elements in B. You could use that at this point because you have all of the other spaces in B taken care of. So you know that you can figure out what this one is, but both F and L need this space to be filled in before we can utilize this information up here. So let's go down here and do this one next. This is telling us that if we take the union of all of these intersections, it's going to be a total of 16. So all of these intersections are these 3 regions that have numbers in them and also this region right here. Okay, so we have 4 regions there that are making up the 3 intersections and then taking the union of all of them. Okay, so if the total in those 4 regions has to be 16 and I already have 14 in there, that tells me that that region has to have 2 elements in it. Okay. Alright, now we can go up here and take care of these 3. So the number of elements in B is 27, so that's all of these have to add up to be 27. So we have 10 and 14, which means I'm going to have a total of 13 in that region. For the number of elements in F, I've got 9 already, and I need, or excuse me, 9 and then 2, so that's 11. I need 25, so that's going to give me 14 elements in that region. And then for the lacrosse, for L, we need 26 total, so that's going to give me 15 in this region. Okay, and then to figure out the number of elements that are out here in the universal set that aren't in one of these sets, we're going to take our total, which is 61, and we're going to subtract all of these numbers from it, because this entire thing has to equal the 61. So if I take whatever I have already and add it up, that's going to tell me how many I need to get up to the 61. So I believe this ends up being, when you add it up, it ends up being 58, and so 61 minus 58 is 3. So there's 3 elements out here in the universal set. Okay, so this is the Venn diagram now that we're going to work with to answer the questions that they're asking us. Alright, so the first question is they want us to find the number of cities that have either baseball or football but not both. So I'm going to see if I can do this in color and see if you can see it. So we want has either baseball or football but not both. Okay, so if you have baseball, they don't say anything about lacrosse, so you know, if you have baseball, actually I don't want to mark this up. We're going to need it for other problems. So let's look at baseball. So either baseball, so if you have baseball, there's 13 cities that have just baseball, and then there's 5 cities that have both baseball and lacrosse, but these 5 that have baseball and lacrosse would count as a city that has baseball but not football. Okay, so there are 13 plus 5 cities that have baseball that don't have football. And then for football, there's 14 plus 2 that have football but not baseball. Okay, so if we add those up, you're going to end up getting 34 there. Okay. All right. The next questions that they're asking us. Okay, part B here. I'm getting this straight. Okay, there we go. So part B here, we want to find the number of cities that has fewer than 2 sports. Alright, so if you have fewer than 2 sports, it either means that you have 1 sport or you have no sports. So that's what we're looking for. We're going to combine those 2 regions on our Venn diagram. So 1 sport, there's these regions here, the 13, the 14, and the 15. And then for no sports, it's actually going to be out here. So there's going to be 3 cities that have no sports. Okay. So if you add those up, you're going to get 45. Okay, so part C here, they want us to find the number of cities that have lacrosse but neither football or baseball. So if you have lacrosse but neither football or baseball, it's another way of saying that they only have lacrosse. And there's just going to be 15 cities that have that situation. That's this region right here. Okay. And then in part D, they're asking us to find the number of these cities that do not have exactly 2 sports. Okay, so if you don't have exactly 2, then you can have 3 sports. You could have 1 sport, or you could have 0 sports. So those are the regions that we're going to want to add together. So 3 sports, there's actually 4 cities that have 3 sports. And then, let's see, 1 sport, there's the 13 and the 15 and the 14. So that's these regions. And then 0 sports, there's 3 cities. Okay, so if we add all of those up, 13, 15, 14, and 3, and we get something let me use my calculator. So I get 49 there. Okay, and that's it for this problem.